All right, here we have another time value of money problem where we're going to help a friend with planning for their retirement. So they plan to retire in 30 years from today, and to help them in achieving their retirement goals, they plan on investing 500 per month in a stock account and an additional 350 per month in a bond account. We have the expected return of both accounts, 11% for stocks and 7% for bonds. And when my friend retires, they plan on combining both accounts into a single account that will then earn 7% in interest. So, given all this, they are wondering how much they would be able to safely withdraw in 30 years from now each month, assuming a withdrawal period of 25 years. So, basically, what we need to do is calculate the future value of both the stock and the bond account. So, what we could do, probably the easiest way to go about this would be by using either the Excel functions or your financial calculator time value of money functions. On your BA2 Plus calculator, there's a row with 5 variables. You would type in each variable individually and then compute the unknown variable. You would have to do that for both the bond and the stocks. For us in Excel right now, what we can do is just uh, the same procedures in Excel. So here, step one is effectively calculate future value of stock and bond account. So stock, bond, and what I'll do is just put the variables kind of here on the left. So what we're given is I'll just go one at a time based on what we're given. So we're given 30 years. So that would be the N or N per in Excel, N on for your financial calculator, which is going to be 30 for both. $500 per month in a stock account and $350 per month in a bond account. So that's the payment, PMT, in both the financial calculator and in Excel. So stock account is 500 and 350 per month for the bond account. I'm just looking at this actually and thinking out loud. This is the number of years, but it's actually not the number of periods because it's per month. So I'm going to actually convert that to years as the input. We're given our discount rate here, rate 11% and 7%. And when they retire, all right, so based on all of this, what we need to do is to calculate the future value. All right, so I'm going to type equals FV here, future value, and I have rate, N per, which is going to be 30 times 12, because I believe, per month. They're making these payments per month, which means there's going to be 30 times 12 total payments. The payment here I'm going to represent as a negative amount for an outflow is this 500. And what I forgot to do also was convert the rate, my bad, into a per month equivalent. All right. Sorry about that, folks. And because I'm in Excel, I can just copy and paste my formula to the right once, and all of my references are dynamic, which means they update to the new variable amounts. So the combined future value of the two accounts is these two amounts here, $1.8 million. All right, so that's step one. Step two is going to be to calculate a payment associated with this. The payment here is going to represent the withdrawal. But basically what we have, we're putting ourselves 30 years in the future, where in 30 years from now, the present value of what we have is this 1.8 million. The R, what they earn in this new combined account is going to be 7% of the rate, and a withdrawal period of 25 years. So I'll put 25 here, and what we need to do is to calculate the payment associated with this. So equals PMT. So I have rate. I'm not going to make the mistake again. I'm going to divide that by 12 because they're going to be withdrawing monthly. The number of periods, will be 25 times 12, and the present value is going to be as 1.8 million. So basically, they can withdraw $12,928 per month for 25 years if they have a present value of 1.8 million in 30 years from now. Now we can validate this. I mean, this is the answer. This is the problem 100% solved. We don't need to go any further than this, but let's just do it. Period. Beginning amount. Interest. Withdrawal. And ending amount. So I'm going to put this into a schedule here, and just to try to validate what's going on. Times that divided by 12. We're going to withdraw this, and that minus that plus that. How far do I need to go? Plus 25 times 12, 300. So what you can see here, what I did is I put this into a schedule where I'm just showing what is going to actually happen in 30 years from now every time they make a withdrawal. So for example, after the first month in 30 years from now, they started that month with this $1.8 million. They will have earned $10,000 worth of interest on that, which is just the 7% divided by 12, multiplied by their principal amount. They're going to be withdrawing this $12,000 though from the account, which will leave them with $1.86 million. Now we calculated that this withdrawal amount will last them exactly 25 years. So 25 times 12 is 300 months in total. So looking at the schedule, if we calculated it correctly, the ending amount of their combined account at the end of their 300th withdrawal should be exactly 0, which is what we see here. Now, the reason I wanted to do this was because it leaves 0 margin for error. So perhaps instead, they want to have some amount of money saved over. Let's say they want to have like a margin of safety of, I don't know, 150,000. We could put that into our EVV calculation here, and then they would have $150,000 left over at the very, very, very end. But that wasn't part of the problem. Oops, I'm sorry, folks. That wasn't part of the problem, so I'm going to take that off. I just wanted to introduce that as a concept for you for your own planning later on. All right, thank you very much. I hope you found this useful. Take care.